to Mahesh and Abhishek to talk about the first paper, which is why do we need to switch to a different DNS model, or do we need to switch to a different DNS model? With that, handing the screen over to Mahesh and Abhishek.
Okay, so let me share my screen. Yeah, 1 second. Would you mind sharing? I think we have a trouble sharing. Ramesh, I think we'll continue with that.
Okay.
I can share.
You can share. Okay, thank you. Thank you. All right. I know this is exciting because we heard so much, like from Dr. Guha and Dr. Ramesh, and this is exciting time, for all of us. Basically, we are way junior, like because to witness another moment in the history that's happening in front of us. So thank you so much for all the insights. This is Mahesh. I'm part of the Project Nanda team. I'm a Stanford alumni and ex-Microsoft. So let me start with the moment that's been floating across every AI boardroom and developer Slack lately. The question, to MCP or not to MCP, A to A or not to A to A, or NL Web, or something beyond. So it's interesting how memes simplify what are actually deep architectural questions, because behind that lies a serious dilemma of AI agents are going to talk to each other across companies, clouds, and even continents. But how will they even find each other, verify each other, trust each other? We all want like smarter agents, better prompts, new benchmarks almost every other day. That the pace is super fast. But beneath it all, we need to pay attention to a most important foundational layer, a registry fabric. At Project Nanda, we have been diving deep into that foundation, researching the quilt of registries needed for Internet of AI agents to function at scale, securely and autonomously. Today, we'll walk you through the crossroads we are at. Should we upgrade our legacy web stack, uh, or to have completely new, like to meet agent era demands? To the next slide, please. Yeah. Okay, so this basically, so this is again, I'm too young to talk about this deja vu moment, but I believe Dr. Ramesh and Dr. Guha can correlate more than me. But this is kind of a deja vu moment, right? So the early internet ran on a dial-up limited to 56 kbps, circuit switched, built by the minute. It worked, like it was not a problem, but it barely worked. But as the web evolved, video, multiplayer gaming, cloud services, dial-up broke down. We needed a broadband, always on, packet switch, scalable. That shift didn't just unlock speed, it unlocked the possibility. So why bring this up in a talk about AI agents? Because history is repeating in a sense. Today's web infrastructure, DNS, IP addressing, TLS certificates, it was built for static websites and passive APIs, not trillions of autonomous AI agents making decisions, migrating, delegating, negotiating as if like a human being or a living thing. So like engineers who saw dial-up ceiling coming, we now see the cracks forming in our registry infrastructure. If we want to unleash the full potential of AI agents, we will need a registry fabric that's more like a fiber than a fax line. So the real question is, will we upgrade our current infrastructure, or do we switch entirely and build a new one for trillions of AI agents? So the next one, please. So here we are capturing like what's actually changing. So traditional web has been reactive. It waits. You or me as a consumer, like click a button and the server responds. The cycle ends right there. There is no memory, no intent, no initiative. But now we are entering the era of proactive agents. These agents are not just endpoints, they are long-lived, LLM-powered digital actors. They interpret user goals, retain memory across interactions, and initiate tasks on our behalf. So think of an AI travel agent that not only remembers your preferences, but negotiates it with airline bots on their own, rebooks your midair or reroutes ground transport, and all without waiting for your prompt. So the current web stack was never designed for this. It was built for human-triggered actions, but now the actors are software entities themselves. So with autonomy, initiative, and state, and that shift in agency changes everything. How we coordinate, how we secure, how we name, and how we govern these digital agents. So the next one, please. Yeah. So let's break down how this shift actually unfolds at the execution layer. Like first, it's a control. In the legacy web, control starts with the user, click to fetch. With AI agents, control starts inside the agent. It decides when to act, what to delegate, and even when to pause. The second one is a life cycle. Like traditional web pages are immutable. REST APIs are stateless. They die after a response, but agents, they persist. They manage state over time, run event loops, schedule future tasks, and adapt their plans. And the third is an identity itself. Today, identity is tied to domains and TLS sets, but agents are mobile. They migrate, they spawn helpers, they scale elastically, and we now need a global IDs, verifiable capabilities, and portable trust. Finally, it's a latency. That's more important one. The web tolerates human speeds, like 100 to 300 milliseconds. Agents operate in a loops under 250 milliseconds, often needing sub 50 milliseconds capability lookups to act fast and in sync. These aren't incremental upgrades, they are qualitative breaks. And each one adds pressure on our registry and coordination stack. It has to evolve or it becomes the bottleneck. So the next one, please. Yeah. So this is like a scale shock, right? So when we put up the term like it's gonna be a trillions of AI agents, like, and everybody's definition of AI agent differs. But if you look at this stack, so we currently have almost like 1.2 billion websites, say 1.2 billion smartphones, but like out of those websites, 70% are still like kind of only actively maintained, and the rest are like digital ghosts. They are more static, idle, or forgotten in a way. And there are 368 million domain names registered across TLDs, but the content they point to over 400 billion web pages. So this was one of the facts revealed in the recent case where Google had to release the Google Analytics, and there are almost 400 billion web pages approximately as of now. And they're all stateless and isolated silos. So the now shift from human use to autonomous computation. So in the age of AI agents, we are not talking billions, but we are talking trillions. Trillions of goal-driven, persistent, and memory-equipped software entities discovering each other, transacting on our behalf, and coordinating in real time. Every one of them will need identity, capability attestation, discovery, revocation, policy enforcement, and audit trails at a machine speed. So the existing web stack that we have simply cannot absorb the magnitude of dynamic state and trust coordination. That's the coming scale shock. And that's why we must rethink the registry layer, not just for capacity, but more for the autonomy. Please. Yeah, so we do have like a limits of the legacy stack. So let's start with the DNS latency itself. In the best case, large providers can propagate DNS updates in seconds, but in the worst case, consumer ISPs may cache aggressively or ignore low TTLs, dragging full propagation to 24 to 48 hours. That's far too slow for agents that mitigate or migrate or spin up in a milliseconds. And then we already have an IPv4, the global free pool that was kind of exhausted in 2011. And what's left is traded at a secondary market with like a 32-bit address cost approximately 40 cents per month. And if you imagine if the scale magnitude of it, like if you multiply by a trillion agents, it's almost like a $400 billion a monthly address cost, and just for the reachability. It's nothing beyond that. The alternative we have is IPv6, like which sounds like the answer, and yes, it offers an astronomical address space, but operationally it breaks down. Privacy extensions rotate addresses frequently, making them unstable identifiers, and injecting billions of 128-bit addresses would detonate global routing tables. So now let's move on to certificates. Like sure, ACME workflows issue certs in seconds, but how about revoking them? Invoking is fine, but revoking them, CRL and OCSP still take minutes to hours in a world of swarm malware or compromised helper agents. That delay is not in a security, it's kind of a security landmine. So the bottom line is that the current stack was built for a different era altogether, like static pages, slow change, human client triggered events. But the internet of AI agents needs the speed, flexibility, and the trust. And today's stack can't deliver any of these. And the most important thing, at a scale. Yeah, the next one, please. So we're kind of showcasing the capability threshold, like how we evolved, like it all started with the endpoint, static HTML files. Then we moved to the REST and GraphQL APIs, like where we added load balancers, service meshes, and the mutual TLS. We've become more transactional, right? Rather than just static endpoints. Then we got workers, like which are serverless functions, cron jobs, RPA, like which can execute behind the scene, and and the CI/CD pipelines can govern them, and they still followed human author schedules and policies. But we have crossed into agents, a qualitatively different category. Agents are autonomous, not reactive. They are goal-driven, can spawn sub-agents, and delegate authority, migrate between runtimes, and continuously adapt based on memory and feedback. This is kind of a capability threshold, and with it come three hard requirements. It's like one is a self-directed and instant discovery. The second is delegated authority and rapid revocation. And the third one is cryptographic proof of behavior to build the trust. So domain names are no longer enough. Like agents must carry attestation of their own integrity, execution logs, and behavioral constraints. So this is where the old stack kind of have cracks in it. So where a new registry architecture must emerge to meet the needs of agentic era. So the next one, please. So we explored the two possibilities, right? One is the upgrade path and one is like switch to a brand new. So let's explore an upgrade path. Like let's say we have an IPv6 dual stack. This gives us the address space, but it needs to be paired with a signed routing manifest to avoid BGP tables explosion from billions of agent prefixes. Second is like there is another solution or kind of a patch applied using RDAP, which is kind of a metadata extension. But right now, RDAP tells us who owns a domain, but agents need more. There is a capability descriptors as non-digest and trust scores, machine readable, and they all needs to be machine readable and verifiable metadata. The third one is when we update a certificates. Okay, that's also an option. So ACME already lets us issue certs in seconds, but revocation is the bottleneck. So we propose short-lived certs with instant stapled revocation tied to behavioral attestations. And the fourth one is stretch DNS itself. New record types like SVCB and HTTPS can embed capability hashes and policy pointers, combine that with DNS push, and we approach sub-second propagation. If resolvers respect aggressive TTL, so that's like if. So the upside, this upgrade path leverages existing infrastructure, the same resolvers, browsers, and certificate chains we already use. But the downside, you carry forward all the legacy, from caching hygiene issues or to slow revocation models or to DNS bottlenecks that simply weren't built for agent scale dynamics. Next slide, please. Yeah, so the other alternative we have is like a switch path, like where we built like a purpose-built registry, which is like first we introduce a like cryptographic namespace, which is not tied up with the DNS, but to a hash derived location independent identifiers and resolvable via overlays like DSTs. We can also have like an identity resolve using global identities. Like agents carry their own verifiable credentials, allowing for direct trust negotiation without a central registry. And then comes the capability first discovery. Instead of looking up an agent by name, you search by a function, like the way Dr. Guha mentioned, right? It's you search for a function, not really like translate in Spanish. So get a ranked list of agents who can prove with trust, and that's not one agent offering that function. Basically, there will be millions of other agents, similar functionality, who can prove with trust, and then they support that capability. And finally, a tiered hybrid registry. Like critical agents like financial or safety related ones are registered centrally, so that we can have it within a walled garden. But the long tail of specialized agents exist in a distributed mesh, like bridged by assigned proofs that enable agents to traverse tiers in under like 50 milliseconds. So this model is built for millisecond level trust, ephemeral actors, and polycentric governance. So pros of this approach is more like unmatched performance and native trust. There is also a cons, like tooling must be reimagined altogether, like it's from the scratch. So adoption will be uneven, and without careful design, there is fragmentation, and we highly touched upon in our earlier discussions as well. So where registries don't interoperate and agents live in the walled gardens. Next slide, please. So sorry. Yeah, so this is kind of a comparative analysis, what we talked so far, like in terms of routing overhead, in terms of latency, in terms of trust anchors, in terms of governance, and the backward compatibility. So we do have a clear benefits from each of these approaches. So that's what kind of we are exploring in our white paper. Next slide, please. Yeah, so more or like, okay, so where do we go from here? If history teaches us anything, it's this. Transitions don't happen overnight, and they rarely happen all at once. So the shift from dial-up to broadband wasn't a flip of a switch. It was a phased hybrid, like a DSL, then cable, and then fiber, each coexisting with the old stack until demand made the leap inevitable. Likewise, the Internet of AI agents will likely emerge in layers. So like near-term upgrades or mid-term bridges and a long-term, like so where we have for example, near-term could be DNS and search and RDAP to unlock the compatibility. The midterm bridges could be hybrid registries that support both central and decentralized models. And a long-term, more or like a purpose-built fabric that treat agent-to-agent interaction as a first-class citizens. And here is the most important part, like the infrastructure we choose won't just determine the performance. It will shape what kind of applications, governance models, and ecosystems are even possible. So we are still thinking about the possibility that this new era is gonna offer us. So this is more than a protocol debate. It's a movement to embed trust, accountability, and resilience into the next generation of the web. And with the registry fabric as our foundation, we can. And the final slide, please. Okay, so we come back to that meme that got popular, right? Like MCP to MCP or not to MCP, A to A or not to A to A. It started as a fun, but behind that was the truth. Everyone's talking about agent communication, agent autonomy, and now multi-agent collaboration protocols, and it's good, so everybody's collaborating together towards the common goal to solve this particular problem. But there is a thing, like before agents can collaborate, transact, or negotiate, they need a registry layer. They need to know who they are talking to. They need trust, names, capabilities, revocation, resolution. Without that fabric, every MCP becomes a fragile handshake in the dark. So what we are building with Nanda is that missing piece, the quilt of registries, a federated foundation for the Internet of AI agents. Whether we upgrade the old or switch to the new one truth remains: the agentic web won't scale without infrastructure built for agents. So to everyone building MCPs, LLM stacks, agentic interfaces, remember, don't just ask MCP or not MCP, but ask whether they're registered and how rough. Thank you. Yeah, and over to you, Pradyumna.
Awesome. Thank you so much, Mahesh. I think that was a very, very insightful presentation on what is the need for a new registry architecture in this web of agents. So with